Welcome to the Sophistic Bridge Design SOFinar part 5 of 6. My name is Matthias Singh, and today we will talk about the design of our frame bridge. So the topic is enveloping and design. And first of all, I will show you each of the steps we have to make to design our bridge, and then I will show you that these steps can be generated also automatically. The Sophistic module CSM, so Construction Stage Manager, offers also just a code check manager functionality, and that's what I'm just going to show you at the end of this SOFinar. So before we will start with the topic, I will just give you just an overview of the functionality of the GoToMeeting software. So you will find a button to display full screen, and you can type your questions into the box which you may have during the SOFinar. If you won't get the response during the SOFinar, you will get it afterwards as soon as possible by email. Okay, and now I would like to give you just an overview of the very important programs for today's SOFinar. So we will need the program SOFiload. So in SOFiload you can define actions, and actions are like containers, and these actions just have the information of the safety factors, of the combination factors, so according to the design code which we just have chosen, and in this case we'll just choose the Eurocode, and the load cases like load case 1 and 2 are just connected with the action. And then we also just have the possibility to make a partition of an action. That means it's possible to subdivide each action with two characters in categories selected with a character from A to Z, and each having distinguished combination coefficients or safety factors like Q underscore A and Q underscore B. So the category will be just appended with an underscore to the name of the action, so to action Q. Then we also just have different types of superpositions, and I just prepared some graphics for you, some more information for that, because this point is just very important. And so you can just define in SOFiload the action with additional, or you can just describe the type of the superposition, and you can use perm. So it's just used for G, so like self-weight, and it's always impermanent, and will be used the same safety factors, as you can see it also in the example. And so if we just have two load cases together in one action, who just makes the superposition, or the program Maxima, who's just responsible for the superposition, calculates at first the sum of this load case number 1 and load case number 2. And after that, the result will be just multiplied with the safety factor. Then we just have PERC, or PERC. It's also always impermanent, but with variable safety factors. Then we just have cont for variable loads, so it's conditional. Then the type of the superposition EXCL is also just very important, especially for live loads. So it's mutually exclusive but conditional, so only within the categories. And I think if you just look at the example, it just gets very clear. So if you just have an action which is called Q with category Q4 underscore 1 and Q4 underscore 2, so if we just use EXCL, you will get the most unfavorable load cases from these categories, so these actions, so from Q4 underscore 1 and Q4 underscore 2, and both load cases will be taken into account. But if you just use EXEX, which you can see here, so it's just mutually exclusive but conditional inclusive category, so only within an action. That means if you just look at the example again, so we just have the action Q and also just two categories, so Q5 underscore 1 and Q5 underscore 2. And if we just use this type, load cases or just only one load case will be just taken into account of the two categories, but only if it has an unfavorable contribution. So that's just the difference between EXCL and EXEX. Then we have UNSC. It's conditional with, so the explanation is just conditional with unfavorable sign. Then we have USEX, so these load cases just have an exclusive with unfavorable signs. And then we just have LX, that means the load cases will be just always but exclusive and only within one action. And here are just examples which I just mentioned. So we just have here perm, or the safety factors are just the same. Then we just have perk, different safety factors and so on. And I don't want to go into details because we don't have the time, but you just can look at the example which you can find here in SSD. Then we just go further. So you can define the load cases and the actions in the load case manager, which we just did in the other SOFinars. Okay, then the next program which will be just necessary is the program Maxima. And in Maxima, different combinations according to the design codes are defined, like the ultimate limit state combination, or also just the other ones like rare or frequent or non-frequent, so according to the design code. And also you can define the superposition, so you tell the program what kind of values, so extreme values, you would like to have, like maximum or minimum, and also for what type of elements, so nodes or beams for example. And what is also just very important, if you just work with the program Maxima, you can see all the superposition results in the report browser, and you will find this layout. It's just important to look at the results. So first of all, you will find the combination rule. Then you will find a list of all of actions and load cases. Then you will find the results of single load cases. Then also just the results of every action, if favorable and if unfavorable. And then you will find also just the final results, so in this case the maximum bending moment my. Okay, then we go further. Then we also just need the program AQB, and AQB just have the capability to make a creep and shrinkage analysis, also just a determination of the maximum stresses in the cross section according to the theory of elasticity. Then we also can make just a determination of the required reinforcement and a determination of the maximum stresses and actual stiffness for the defined material. Okay, then I just want to switch to SOFi Plus. And now I would like to show you the additional loads which I just have prepared for the superposition. So we're just starting with the load case number 1. Load case number 1 will be just used, or will be just needed for the self weight. Then we just have load case number 2, that's for the cantilevered parapets. Then we have load case number 4 for the return walls. So these are just the load case of the other SOFinars, which you already know. And load case 11 is just necessary for the pre-stressing of the tendons. Added here the new load cases, so from 20 to 26 we have the temperature loads. I don't want to go into details because it's just based on the Eurocode, and you will find all the necessary information in the Eurocode. Then I also just added wind loads, also just according to the Eurocode, which you can see here. So here and here. And I added just 4 wind loads to the project, just to make a superposition also just with more variable loads. And if we just go to the load case manager, you can see that I added just new actions. So we just have here temperature loading action and also just a wind loading action. And if we just look at load cases, you can see that the temperature loads doesn't have any action. So I just use the action none. And I will just tell you now why I just used a non-action. So if we just go to SSD without making an export, because I just did it before and I also already calculated everything, and I already defined all the text editor tasks which we're just going to use now, or which I'm just going to show you for the SOFinar. So if we just look at the first sheet, so in the group additional load cases, I just added the text editor task temperature and load combination, and here you can see that we are using now the action T, which is just defined in the load case manager, so for temperature. And now you can see that the load cases which I just defined in SOFi Plus will be just copied to the load case 80. So the load case 20, 22 and 25 with factors will be just inserted to the load case 80. I just created 12 load cases for the temperature. So today we will just want to talk about enveloping and design. That's why we just switch immediately to the group enveloping and design and to the first text editor task, definition actions for pre-superposition. So in the program SOFiLoad, I defined new actions like y_d or y_1, and so these actions will be like containers, and we're just going to make in the program Maxima pre-superposition for the variable loads, and these results of this superposition will be just stored in these actions like in y_d, for example. And you can see what pre-superpositions we will just make. So we can make just a rare, non-frequent or frequent permanent pre-superposition, for example, but what is also just very important to notice is without GPC. And if we just switch to the next text editor task, you can see that we just are now in the program Maxima, and in the program Maxima you can just create combinations or superpositions, and we just making it first a pre-superposition of all the variable loads. So we are using only the actions of the variable load, so it's gr_t, which is just responsible for the tandem system load. Then we have here gr_u, uniformly distributed loads, and horizontal loads, and temperature and wind loads. And Maxima just has the capability to make also just different kind of combinations. So in this case we're just making a combination on ultimate limit state design level, so we are using DZ. If we just look in the manual, if we just press F1, you can see also that you also just have other options like perm, rare, frequent, non-frequent, and so on. And these combination or this superposition, which will be just done of the program Maxima, will be just stored in the container, so in the action y_d. And this container will be just needed for our final superposition in the program Maxima, and also for a superposition in the program AQB. And then we can just tell the program the definition of the superposition, so what kind of results we would like to have. And here you can define the element type, then the type of result we would like to see, then where the result should be just stored, and you also can choose the specific element number. And if you just choose a specific element number like 1,020,010, you also just get specific results. But if you just choose the default, so 1 to 999,999, get just results for all the elements. And then you just have to tell the program what kind of, so the type of the extreme value, and we are using, or we want to have the maximum and minimum. And then we also just have to write the combination number again, which we just have used above. Okay. And of course you can just do a combination also for all the other kinds of combinations which are just based on the Eurocode, like rare and frequent. But just to keep it our example simple, I just want to show you just the ultimate state limit design combination. The next text editor task. So here we just have a frequent combination. We're just using also just of a container, as you can see it here, and we're also just using here the freak, so extra freak in the record comp. Then we just go further to the Maxima, so to the final superposition, and the superposition in program Maxima just works always on the same procedure. What is important to notice is that we are using here the GPC, so the load cases, so the self-weight, the pre-stressing, and also the creep and shrinkage. And we're doing also just here our ultimate state limit design, and that's why we also just have to use this container, which we just defined before. So in this container, the pre-superposition information are just stored, and then what is also just necessary to say is that we are using the 5000 load cases, and they will be just created by the CSM program, so with the help of the CSM program. And these are just the different load cases, and that's what I just explained in the third part of the SOFinar. And if you just need more information to the generated load cases of the CSM program, you can just look at the manual of the CSM program. Okay, and then we also just have to tell the program what kind of results we would like to have, and where they should be just stored. So these results, so like bending moment MY, or just for the quad, the bending moments will be just stored also just in this load case. And you can see that we are using here also just the same load case, so you can use the same load case number for different element types. And we are also just looking at extreme values, so like we are looking at maximum and minimum. And then I just prepared also just 2 graphics to show you what is possible. So I just prepared 2 graphics, so for the minimum support force in PZ direction, and then we just have a force of 1368 kilonewton, and the maximum is 2534 kilonewton, also just in the same direction in PZ direction. And you also can see the load case number where the result is just stored, so in 2125. Okay, and then we just have here also just a final superposition on serviceability limit state, rare and frequent, but it just works on the same procedure, so I don't want to go into details. And then we also just have the final superposition, but with the upper and lower characteristic values for the variation of pre-stress for the serviceability limit state. And so we just look inside, you can see that we have here that the pre-stressing will be we just multiply with additional factors, so with the factor according to the Eurocode. Then we go further to AQB, Superposition Manual ULS, so Ultimate Limit State Design. And you can see that we're here just making just additional, or that we're just making here also just a combination, so a superposition. And we are using here the 5000 and the 6000 load cases. And you can see also here that we are using the action y_d, so the container, where we just defined the pre-superposition before in the program Maxima. Okay, and so the question is, why do we have to make just the additional superposition in the program AQB? And I just prepared also in the PowerPoint some graphics for you. So first of all, I would like to review what I just showed you in SSD. So we just used the temperature and also just the live load or the variable actions. We just made just a pre-superposition, but before we just I just showed you that I defined in the program SOFiload actions, so containers, for the pre-superposition of the variable loads like y_d for the ultimate limit state design, so just for the design combination. And then we just made our pre-superposition but without GPC at first. And then so this pre-superposition information is just stored in these containers, and then we're also just using the GPC loads, so the dead load, pre-stress and creep, and these are just the load case. It was just created of the program CSM, so these are just the different load cases, the 5000 load cases. And then I just made the final superposition with GPC and the containers, and then I just showed you in the last text editor task that I just made another superposition in the program AQB, and also just with the 5000 and the 6000 load cases and the container y_d. So if you just imagine the construction stages of our frame bridge, so we will just have a cross section with a hole of the tendon, then we will have the pre-stressing of the tendon, and then we will have the grouting of the tendon. So in each of the construction stages we will have different cross-section properties, and that means that different load cases will be also just loaded on different cross-sections. And only the program AQB is capable to consider the different stress stages of the cross-sections in combination with the corresponding loads. And that's why we also just have to make a final superposition in the program AQB to get the real internal forces of the cross-section during the construction stages for the beam elements. And we are also just making a superposition in the program Maxima to get just the results, so like the maximum results of the nodes or just the quads, for example. And so that's why we just make two superpositions. And you can see it here also just in the next graphic that you can just define in the program AQB first of all the load cases, and then you can tell the program when the load case, for example load case 8 will be just active. So the load case 8 will be just active at stage number 8, but the pre-stressing load case 5011 will be just active at the stage number 11. And only the program AQB is capable to consider these different stress stages. Then we just go back to SSD. So first of all I just add all the load cases, so the 5000 and also just the 6001 for creep and shrinkage. Then you can select the beam element number in this record, so beam, and then we just can see here that we can make here the combinations like also in the program Maxima, but it's just a bit different. So first of all we just have to define what kind of results we would like to have, so maximum and minimum, and then also what type of results. So in this case we are looking at the bending moments, also at so also just on the shear force and the torsional moment. And these results will be just stored in these load cases, so the minimum and the maximum, and then we're just going to make here the superposition. But you can see that G, P and C doesn't have any factors, or there's no factor just written here, and the reason for that is that we just have to define here next to the type of the value we would like to have, so in this case maximum, we just have to define just additional letter. So D means it will be just based, so the combination will be just based on the design combination. That's why we just have a D here. But if we just look at the manual, you can see that you also just have other possibilities. So D stands for design combination, but if you just use A, it's just accidental design combination, favorable and unfavorable, or just earthquake, then you just have to use a E, for example. And then we also just have here a combination, so G max and G min, and then we will just get the maximum and the minimum values of the results will be just stored via this load case number in the same format. And we just make here just our ultimate state limit design, and so then we just have to use directly a DZ state ulti. That means we can make our design based on ultimate limit state level. Then we also just can use the record tree, and that means we can make a stress check of any thick-walled and thin-walled cross-section, including shear stressing and warping torsion. And you can just find more details in the manual of AQB, as you can see it also just on the left side hand. And also just important to notice is the record NSTR, so nonlinear stress and strain. And the record NSTR, nonlinear stress and strain evaluation determination, is performed with this record. And so, as I just mentioned before, more details are just available in the manual of AQB. So so we just made a superposition in AQB, and also just prepared some graphics for you. So if we just look at the report browser of the WinGraph task, you can see that we have here the bending moment My based on the ULS design for 5,577 kilonewton meters, 77 kilonewton meters, but only for one girder. And then we have here the minimum bending moment My, so minus 10,000. Then we have here the shear force, the torsional moment, and also, what is also just very nice, is the minimum reinforcement which will be just needed for the ULS design combination. So here we just have the results of the longitudinal reinforcement, so total. Then we have here the longitudinal reinforcement at layer number 1, so which will be just the bottom of the cross section. And then we have here the longitudinal reinforcement at layer number 2, which will be just the top of the cross section. Then I also just made a superposition in AQB for the decompression check, and you also can see that it works just on the same procedure. I just defined here the 5 and 6,000 load cases. Then I just used other containers, so the Y_4 container, which is just defined here in the program Maxima and the pre-superposition. And here I just have here also just a combination of G, P and C, and here P with a additional factor according to the Eurocode. And here we're using the load case number 4, so the action Y_4 with a factor of 1. And it's just important to notice that we have to use here just a factor of 1 because we already did the superposition with the factors in the program Maxima. Okay, and now I would like to show you how we can just generate all of the steps which I just showed you automatically. So if we just go to the next text editor task, so superposition of the following CSM design, you can see that we're here in the program CSM, and we just defined here actions, but as you can see only the variable action. So we just have here the action for the uniformly distributed loads, tandem system loads, horizontal forces, and also just for the temperature and wind loads. And the GPC loads, so for self-weight, pre-stressing and creep and shrinkage, will be just taken into account automatically by the program CSM. And then we just have to use then the record DZ, and you can see here in the manual that we have different options like max, or which is also just very important to notice is ulti, so for ultimate design, or deco, so decompression check, or also just very nice is just a check print, which you can see just in the next text editor task. And with this record, with DZ max and the next line, which you can see, so with plus apply and the name of our project, so FrameBridge, just an additional dot will be just created. And in this dot you will find all of these steps here. So you will find the pre-superposition, So you will find the definition of the actions for the pre-superposition, then the pre-superposition for ULS and SLS, and I think we're just going to look inside to make it just a bit easier. So it will be just called framebridge underscore maxi dot. And first of all, you can see that 1,300 lines has been created by the program CSAM, and it starts just with a proc template, and here you will find just a description for the superposition and design concept of SOFistic, and then we just have here the definition of the action in the program SOFiload, which I just showed you. So the containers for our pre-superposition. Then we have here the pre-superposition of GPC, and down here the final superposition, but not only for design for ultimate state design, also just for rare or frequent or permanent. And you can see also that the definition of the superposition is also just created automatically. So what kind of element, what kind of result, and where the result should be just stored. All of these steps will be just created automatically. And we also just have here final superposition with the characteristic values for the pre-stressing variation according to the Eurocode. And so if we just go back to SSD, so these steps, so from the first text editor task to this text editor task will be just created automatically. And if we just look at checkprint design, so this text editor task, so this is just very helpful. If we just use DZ and then check, just a short and clear output can be just achieved, and with this checkprint we can verify the stress in one beam in defined stress points. And I just want to look inside of these dot. So if we just open our file where our project is just stored, there you will just find the text editor dot, and here you can see what has been created automatically. So first of all, the template again, and then you will find the checkprint of the single action components, and here we just include the 5,000 and 6,000 load cases from the CSMLF dot. And if we just would like to see what is inside, you can just make a right click on it, and then you can just open the include file. And there you can see that these load cases will be just included automatically to this line. And then you can see that for a specific element number we will get just the results of the combinations which are just written here. So we will get just the bending moment, so the sum of the bending moment for G1, G2, GPC, and also just the maximum and minimum bending moments for the actions which we just defined before, as you can see it here. And also, what is also very nice, that automatically combinations like where, frequent, perm will be just created automatically, and you will find the results in these load cases, as you can see it here. Okay, then we just go to the next text editor task, to the last one, and you can see here that we have here 3 records. So we're using here deco, ulti, and 6. So decompression check, ultimate design, and stress checks. And if we're just going to run this sheet, you can see what's going to happen. So it just starts again with a template and AQB results, AQB, AQB, and let's WinGraph graphics. So first of all, I would like to show you the reports or the report browser, and it just starts with the actual stress in the cross section for the stresses. So these will be just created automatically by the CSAM program. And then we just have here, for example, the necessary reinforcement of the ULS design, which you can see here. And also just for the longitudinal reinforcement, so these are just the graphics which I just showed you before. And then also just the maximum compression stress will be just created, as you can see it here, so just a graphic for it, and so on. So you will just get a lot of information, and also just the maximum minimum stress decompression permanent, which you can see here. And if you just look into this dot, so with the name framebridge_DZ, you can see also just what's inside. And you can see that 580 lines has been created automatically. So it just starts with the ultimate limit state design. That's what I just showed you in before. Then we have just here a stress check for nonlinear concrete stress, and so on. Then we just have here the maximum tending stress, and also just the other stress checks like decompression check. So thank you for your attention. I hope you just enjoyed this SOFinar. Before we're just going to finish this SOFinar, I would like to give you some information for the next SOFinar, so for the part number 6. So if you just go to our homepage, sophistic.com support training, and at the schedule at part 6, you can just have just the option to input your questions into this box, which you can see at the right hand side. And we would be just very pleased if you just would have some questions for us. Okay, so that's it. Bye.